The diagram shows a triangle PQR with PQR equals to 37 degrees. S is the point on QR such that PSR is equals to 90 degrees. PS is equals to 8 centimeter and SR is equals to 5 centimeter. Calculate PR. Okay, the very first thing is finding out the value of PR using this right angle triangle, which is triangle PSR. So for part one, we are going to consider triangle PSR and we have to find out the length of PR. This one is very straightforward. PR is the hypotenuse of the right angle triangle. So I can just simply apply the Pythagoras theorem to find out the length of the hypotenuse because I have the adjacent and the opposite. Hypotenuse square is equal to base square plus perpendicular square. So I can write it this way. PR square is going to be 64 plus 25, which is PR square is equal to 89. In order to find out PR, we'll take a square root on both the sides. So this square cancels this square root. PR equals to square root of 89, which is 9.43. This is going to be 9.43 centimeter. So this length over here has become 9.43 centimeter. This is part one. Let's see what do we have in part two. The shortest distance from S to PR. The shortest distance from S to PR, whenever we say calculate the shortest distance from a point to a side, then we are actually talking about the perpendicular dropped from that point to that specific side. So the shortest distance of PQ from S is going to be this perpendicular from S on PQ. Let's say this is the perpendicular which I have drawn, and this side is not equal to this. Okay, so this is not equal to that. First thing, you make sure that you do not take them to be equal. Let me try and make it a little better. This is the perpendicular. Let's just suppose that this is the perpendicular. I'm trying to draw a better part, but the more I'm trying, the worse it is getting. So let's consider that this is the perpendicular, right? Okay, this is the perpendicular, and the angle between these two is 90 degree. Okay, we have to find out this length, this blue line which I have drawn. Problem here is this, that this is a right angle triangle, and in this right angle triangle, I only have an angle. I do not have anything else here. So finding out the perpendicular becomes a little difficult in this situation. What we have to do, we can maybe use the area of triangle formula to find out that perpendicular distance. But the problem is this: we do not have the area. So what must be done? Okay. Can I use the trigonometric ratio? I would have used it if I had known one of the sides of this right angle triangle which I've just constructed. Means I can find out the value of x if I knew this, or maybe if I knew this part, but I do not know any one of them. So the first thing that I must do is to find out the length of Q2S somehow, or maybe finding out the length of Q2P. Finding out the length of Q2P uh, will not help, because if I calculate the length from Q to P, then I do not know how much is the length from Q to, let's say this point is A. Okay, even then I'll not be able to, because as I mentioned earlier, please do not take these two halves to be equal to one another. So even if I calculate P to Q, then I'll not be able to figure out what is the length of QA. So the only option that I have left is finding out the length of QS. Is there any way we can find out the value of QS? Yes, there is a way. If I consider the triangle PSQ and apply a trigonometric ratio there to find out the length of QS, that will help me finding out that line from A to S, the blue line which I have drawn. So the first thing, instead of calculating the length of X or the value of X, the first thing I have to find out, the length from Q to S, for which I am going to consider the triangle PSQ. I'll consider triangle PSQ, the whole triangle. This is the one that I'm referring to. This is the one. Okay. So I'll be using this triangle. In this triangle, I have an angle. I have the opposite. I am trying to find out the adjacent. So I'll be using trigonometric ratio, that is tangent 37 is equals to opposite is 8 and adjacent is QS. In order to find out the value of QS, I'll move QS to this side and bring tangent 37 over here. So QS is equal to 8 upon tangent 37, which means QS. Let's divide 8 with tangent 37. 8 divided by tangent 37 is going to be 10.61. This is going to be 10.61 centimeter. This is QS. Why was I trying to find out QS? As I mentioned earlier, that in this triangle, I have to find out the value of X. This is again a right angle triangle. Problem here was I did not have any of the sides of the triangle known, but now I have found one. The one which I found out is QS, which is 10.61 centimeter. Now I can consider the triangle QAS. Let's say I'll consider the triangle QAS, and in this triangle, I have an angle. I have a side, and I have to find out one of the sides. The side which I know is opposite to right angle. This is opposite to right angle, which means 10.61 becomes the hypotenuse. I know the hypotenuse. I have to find out x. X is opposite to the angle which is given to me. So x becomes opposite for me. Okay. I have to find out opposite. I know the hypotenuse and I know the angle. The trigonometric ratios which connect opposite and hypotenuse is sine. So I'll say sine 37 is equal to x opposite upon hypotenuse 10.61. I'll move this 10.67 over here. Let's say what is sine 37 equal to. Sine 37 is 0.601, and this is going to multiply with 10.61. I'll be left with x on this side. Just multiply this with 10.61, and this is going to be 6.38. So the value of x is going to be 6.38 centimeters. So the shortest distance from S to PQ is going to be 6.38 centimeter.